All right, welcome back. Today is going to be, I think, a pretty fun lesson. We're going to kind of jump into some real world problems, story problems with systems of equations. I think they're kind of fun to solve. So let's go ahead and get started with this. Now, one of the first things that you're going to have to do is identify the two variables that we're talking about, the two unknowns in this situation. And after that, we're just going to kind of write down what we see. Another big key to this is anytime we can find a total and put that after the equal sign, that's going to be pretty helpful. So let's see what we can do. So this first one, a student has some $1 bills and $5 bills in their pockets. They have a total of $10 bills that are worth $34. So here's what I see. I see a total right there, a total of 10 bills. So I'm going to write that after an equal sign. Equals 10. And then they also have the total value of that is $34. Okay, so they have $1 bills and $5 bills. Maybe I'll call the $1 bills X and $5 bills Y. Okay, so let's put an X and a Y in both of these equations, and I'm pretty sure that I'm going to have to add them some way. So that's looking pretty good. Now, there's one other thing that we need to do here. $1 and $5. I need to put those in these equations somewhere. And so the question is, do I put it in the top equation or the bottom equation? Well, $1, $5 seems like that's going to go with $34. So the 1 and the 5 are going to go in the bottom equation right here. And on the top, just X plus Y equals 10. The number of $1 bills, the number of $5 bills is 10. All right, so let's go ahead and solve this. Right here, the X's are just about ready to eliminate. All I need to do is change the signs. So I'm going to change the signs, either the top or the bottom. I might change them on the top. Let me put it in red so that we can tell that they're actually been changed. A negative X, a negative Y, and a negative 10. And then let's go ahead and solve this. Negative 1x plus 1x is 0. That's just eliminated. My negative 1y plus 5y is going to be a positive 4y. And negative 10 plus 34 is going to be 24. Easy from here, divide the 4, and we'll get y equals 6. So it looks like I have 6 of the $5 bills. If we go back to this original equation that we wrote up here, where we had x plus y equals 10, that's the one I'm going to use. I'm just going to sub 6 in for y. So I've got x plus 6 equals 10. Last step, subtract the 6. X is equal to 4. So it looks like I have 4 $1 bills and 6 $5 bills. All right, let's do another one. A music program has 8 solo acts and 3 ensemble acts. So it looks like what I'm going to be talking about here are solos and ensembles, okay? I could probably write that down right now. Maybe we'll just read it a little bit more. The show will last 72 minutes. That's a total. A total. So I know 72 minutes is going to go after the equal sign. The next night, the 4 most popular solo acts and all the ensemble acts will have a second performance that lasts 48 minutes. So this one, the total is going to be 48 minutes. How long is each act? Okay, well, let's go back, and I'm going to erase that 48. Make it a little bit easier to read. Let's go back and read it. The first one says 8 solo acts and 3 ensemble acts last 72 minutes. So let's just write that. 8 solos plus 3 ensembles equals 72. The next night, the 4 most popular solo acts, so 4 solos, and all the ensembles, well, it already told us that there was 3 ensembles. So 3e equals 48. Okay. Well, we could multiply the top by the bottom by the top, and cancel the s's. We could multiply the bottom one by 2 and then cancel the s's, or we can just see those e's are just about ready to be eliminated because they're both 3's. So I'm going to change the signs on the bottom equation. Make that a negative 4s, a negative 3e, and a negative 48. And let's solve these. So 8s minus 4s is just going to be 4s. And the e's will cancel. They're eliminated. And 72 minus 48 is going to be 24. Divide by 4, and we're going to get s equals 6. So each solo act is 6 minutes. Now I can use any equation that I want. Maybe I'll just use the top one. 8 times 6 plus 3e equals 72. So 8 times 6 is 48. So let's subtract the 48 over. 3e equals, well, same numbers as last time it looks like. 24 divided by 3, and we'll get e equals 8. So every solo act was 6 minutes, and every ensemble was 8 minutes. All right, let's keep rolling. Movie tickets can be expensive no matter where you live. If you buy 4 tickets in Mexico and 7 tickets in England, well, that sounds like our variables. Let's just write these down right now. 4 tickets in Mexico plus 7 tickets in England, you will pay $73.75. If you buy 3 tickets in England and 5 tickets in Mexico, 3 tickets in England and 5 tickets in Mexico, you will pay $56.25. How much does it cost per ticket in each country? Okay, now, maybe you saw me kind of make a mistake in this already when I wrote these down. The mistake that I made was I didn't line up our E's and our M's. Be very careful. This problem is tricky because they give it to you in different orders. I'm going to change that in this second equation. I'm going to put the 3E under the 7E and the 5M under the 4M. So this was 3 tickets in England and 5 tickets in Mexico. All right, now we're going to have to multiply the top by the bottom and the bottom by the top here. So I'm going to multiply the top equation by 5 and the bottom by 4. So we will have 20m plus 35e equals, let's see what that is, 73.75 times 5 is going to be $368.75. Now let's do the bottom equation. So 4 times 5, that's going to be 20m plus 12e equals 56.25 times 4 is going to be $225. Okay. Now, the m's are the same, so they are ready to eliminate. Let's change the signs on the bottom. So I'm going to make that a negative 20m, a negative 12e, and a negative 225. So let's add them now. The m's will cancel. They're eliminated. 35 minus 12 is going to be 23e. And 368.75, let's see what that is. 0.75 minus 225 equals $143.75. Okay, last step, divide by 23. And we're going to get $6.25. So in England, the ticket is $6.25. Okay, so let's find out Mexico. So I can use any one of these equations. I think I'm going to use the top equation right here. So I would have 4m plus 7 times 625, running out of space, equals $73.75. Really running out of space here. So 4m, what's 7 times 625, I wonder? That's going to be $43.75. So I'm going to subtract that over $43.75. I'm sorry, I hope you can follow this. This is really getting crowded here. Equals $30. 73.75 minus 43.75 is 30. So then when I divide that by 4, I'm going to get M equals $7.50. So it looks like in England, there's $6.25, and in Mexico, there's $7.50. Let's see. Yeah, we've got one more problem here. Okay, 2 burgers and 3 orders of fries have 2,085 calories. Let's write this down. 2 burgers plus 3 orders of fries have 2,085 calories. 3 burgers and 4 orders of fries contain 2,990 calories. Okay, how many calories does each item contain? Well, we need to, once again, multiply the top by the bottom and the bottom by the top. So multiply the top by 3, the bottom by 2. So when we do that, we're going to have 6b plus 9f equals 6,255. And on the bottom, 6b plus 8f equals, what's that going to be? 5,980, I believe. Okay? All right. Now, let's change these signs on the bottom, because we have to, remember, we have to change them because both of those 6b's are positive. So that's now a negative 6b, a negative 8f, and a negative 5,980. Okay, so the b's cancel. 9f minus 8f is just 1f. That's nice. And 6,255 minus 5,980 is going to be 275. So an order of fries has 275 calories. Go back and choose any one of those equations. I'll choose the top equation. 2b plus 3 times 275 equals 2,085. So let's see what 3 times 275 is. 825. So let's subtract 825 over, and we're going to get 2b equals 1,260. Then divide by 2, and we're going to get b equals 630 calories. All right? So that's what we have. An order of fries is 275, and a burger is 630. All right? So hope you enjoyed this lesson. Hope you understood it. If not, maybe go back and watch it another time. All right? I know you got it. Good luck.